of loops, we have two more loops. So there are many loops in PascalABC.NET, and as well different languages, programming languages, have similar loops. While loop and repeat loop. For example, C++ language also has while loop, no repeat loop, but while loop. Java also, and different languages has the same loop, while loop. Repeat, it's just individual for PascalABC.NET. Not each programming language has this one. So let's look at the syntax of these loops. The first is a while loop. So if we are going to repeat something until condition is false. So we have some condition. For example, it must be Boolean type. Boolean type, it means that it's logical. For example, if x is greater than 0, we need to repeat some statement. So the condition must be logical, yes, and while this condition is true, we are going to repeat something. So if we have, for example, x equals to 10, so we need to repeat it. To repeat this statement or to repeat some statements. There can be some statements. But if we have some statements, we need to have here begin and end. The same as we had for loop and for loop. The syntax is while keyword, then you have your own condition. You have to write it down. It depends on the task. The condition depends on the task. We don't know what must be here. Just for each task, we have our own condition. Then we have do keyword, and next line or some lines of body of the loop. So some statements to repeat. To repeat until condition is false. If we have condition false, the repetition will be stopped. And as for repeat loop, it's very similar to while loop, but the condition will be after the loop. So not in the header of the loop, but after the statements to repeat. So first we need to type this keyword, repeat. Then we have the statements to repeat. It can be one statement or some lines of code. And then we have until keyword, it's the keyword. And here we have the condition. Not in the header of the loop as for while, but after, until condition is true here. So if the condition is true, we must stop these repetitions. If the condition is false, we need to repeat it. Repeat, and again until condition is true. So here we repeat until condition is false, and here we repeat until condition is true. So a bit different, yes? Okay, so let's look at the examples of these while and repeat loops. So it is again about the syntax, and let's look at the example. For example, we are going to output this sequence 0, 1, 2, 3, 4. So we have to have the counter. The counter just to be increased by 1, yes. And the initial value is equals 0. The initial value equals 0. So x is set to 0. Then we have a keyword while, and we say that while x is less than 5. because we are going to go up to 5, but not including 5. Yes, not included. So while x is less than 5, we are going to repeat some lines of code. Which one? To print out our counter. So the first iteration of the loop, it will be 0. Then the counter must be increased by 1 to have the next one. Yes. Then we have to go again here and to check if x is less than 5. Yes, 1 will be less than 5. Yes. So we are going to print it out. 1 will be here. Then x will be increased by 1 and it will be 2. Then the compiler will check if 2 is less than 5. Yes, it's less. So we are going to repeat it again. It will be printed out. The 2 will be printed out. Then we will have to increase our counter. It will be 3. 3 is less than 5, so it will be printed out and increased by 1. 4. 4 is less than 5, so we need to output this. And then we will have it increased by 1, so it will be 5. And 5 is not less than 5. So the condition will be false. And the compiler goes here. It will not repeat it again because the condition is false. And goes here. And for example, here we have the end of our program. End. So we will see these numbers, this sequence, in our output window. And let's look at the same example, but the example using repeat loop. So the same with repeat loop. So again, before the loop, we need to set x to 0 because the initial value have to be 0. Then we have a repeat keyword. And print, this is the body of the loop, and note that we don't have here begin and end. Yes, we don't have here begin and end because we know where it ends. Until means the end of the loop, of repeat loop. Until we have here. Here we don't have this until keyword, and we need to put begin and end to understand where the body of the loop ends. But here we know where it ends because until is the end of repeat loop. Okay, so we repeat printing x, it will be 0, then x will be increased by 1, and then we check until 0 is greater or equals to 5. No, it's not greater, so we need to repeat it. Again, we have 1 printed out, this printed out, and then we increased it by 1, it will be 2. And we check if 2 is greater or equals to 5. No, it's not. So we need to repeat it again. 2 will be printed out. And it will be increased by 1, it will be 3. And again, 3 is not greater or equals to 5. And again, we print it out, increased by 1. Check if 4 is greater than 5. No. So we repeat it again. So 4 will be printed out, increased by 1. So it will be 5. And x 5 is greater or equals, yes, equals to 5. So it is equals, so we don't need to repeat our loop again, and the compiler goes here. After the loop, we have, for example, end of our program. And that's all. So we have this sequence printed out. So it's the comparison of how to do the same task using different loops, the while loop and repeat loop. Do you see that repeat loop? It's individual for Pascal, and it's a bit strange because it will be repeated. It will be the body of the loop executes one time always, at least one time. For example, we have a condition here until x is greater or equals to 5. And if we have, for example, 5 here as initial value, so the body of the loop will execute. Will execute because the compiler don't see this condition. It prints out 5, for example. It will be increased by 1. It will be 6. And then the compiler understands that 6 is greater than 5. So I don't going to repeat it again, yes? And it will go there. But one time it was executed. Yes? So here we have the condition first. So if we have 5 here, it will be not printed out, because the compiler see that 5 is not less than 5. So I will go there, I jump here, and I will not do it. But here he don't see the condition. It prints out 5 and then it sees this condition. So at least once the body of the repeat loop will be done. So it's in comparison with the while loop. It's the difference between them. Okay. And now it will be better if you repeat it after me. Or just look with more attention as I do it and as I explain it for you. So this task, and I will open my pascalabc.net to see the results. I will do it like here. So first we are going to copy this task. As always, we copy it and paste it in curly braces to have it as a comments. Yes, I just repeat some things for you. Just as a rule, you have to do it always as a rule. Okay. You can do it just in several lines of code. So what we are going to do here? We are going to see this sequence of numbers. And as you see, they are real numbers, not integers, but reals. Yes, we have a fraction here. And we are going to output these numbers using the loops, while loop and repeat loop. Yes. So first initial value of the counter will be 0.1. And the last one will be 1.1. And we need to output this between them using the loops. So let's do it. We start as always with begin. By the way, if you have the question, yes, you can ask me. Okay, so I will do it and you are to ask the questions if you have. So we are going to start, begin. Then we have to put this as the initial value of our counter. So we have some counter, let's call it x. And then after we need to have this initial value. So it will be, just a minute. It will be 0.1, as we told it. We have to assign 0.1. Okay. Then we have the header of the loop. So all the rest values we need to have using the loop. Yes, to print them out using the loop. So the header of the while loop, first let's do it with while loop. While. So we need to have this keyword while. Then we put the condition. The condition, so this x must be increased up to 1.1. Yes, so the condition will be while x is less than less or equals to 1.1, because 1.1 must be outputted 2. Yes, so while condition, then we have do, and then we will have some lines of code, and we need to put begin and end. So I'll put begin, and here will be the end. Okay, so first we need to print out the initial value, so we are going to print out x. Yes, we need to put here print x. Then we need to increase x. What must I add to have the next value, and the next value, and the next value? What I must add to x? I need to put plus equals to what? Can you tell me? To have the next value, what I have to add to x?
We should add 0.2.
Yeah, correct, right? 0.2, bright, yes, correct. It's bright, yeah? Bright told this.
It is Farhood.
Farhood, yeah. Thank you. Okay, so it will be, and everywhere, do you see everywhere, 0.3 plus 0.2 will be 0.5, yes? And again plus 0.2, it's always between these numbers, yes? So we need to increase this x by 0.2. And we call it the step of the loop. Because the counter of the loop, here we have it, have x as a counter of the loop. So we have it increased by this value, and it means the step of the counter of the loop. We call it step. Okay, so that's all with while loop. So if we start our program, if we run this program, we will see these results. Yes, the same as we have it here. So it was they were printed out due to these lines of code, due to these repetitions. So while the condition is true, we do it. We do these lines. We repeat these lines. When the condition was false, so the last one was 1.1 plus 0.2. It was 1.3, and the condition was false. And the compiler jumps here, and it was the end of the program. It was the last repetition. I tell it about the last repetition. And the same we need to do with repeat loop. So it's really similar. So after this, we will have the same, but you must understand that we must have again initial value of x, because when we terminated this loop, x was 1.3. But we are going to have the same results using repeat loop. So we need to have initial value again. So we can copy this one without var because it was already defined. So again, we have initial value. And now we are going to start with repeat keyword, repeat. Then, do you see that Pascal.abc.net helped me? He make it itself. So until and space to have the condition. So, but first I want to have the body of the loop. So first we are going to output this print x. Then again, I want to increase x by 0.2. So it will be x plus 0.2. And then I want to have the condition. So we are going to repeat this loop until x is 1.1. X is 1.1. Or we can do it like x is until x is greater. We can do it greater than 1.1. Okay, so let's try to do it. Oh, until no, not. I have the loop, infinite loop. Yes, do you see it? Infinite loop. So I have wrong condition until x. Plus, I forgot about plus here. Plus equals to, because the condition is correct. Yes, I forgot about the plus. Okay, so here we have good results, but they were just inside one line, and it's not good. Yes, so to make a new line, we will do here between the loops. We will have print line statement to have a new line. Just print line. Okay. And now we have good results. We see that the first one was done using the while loop, and the second one done using the repeat loop. And the results must be the same, and they are. Okay, after you will have to copy this name of the file and to save this file with this name. Yes, to save it and to send it to me using the chat. But you will have your own task now. But before you do the tasks, please tell me if it is clear, or maybe you have some questions. No question. Yes?
I have no question.
No questions. Okay, so it is clear. And now you are to do the tasks. I will just copy them, the numbers. So we did it. And by the way, here we have some step for our loops. But if we want to do the same task, to output this sequence of numbers, floating point numbers, and we are going to use for loop, not repeat, not while, but for loop. Let's do it here, and it will be more complicated, but we can do it using for loop too. So we need to use a so-called arbitrary step, because the step is not 1, so the counter increase not by 1, but some arbitrary step. Here we have 1.1 step, and if we have for loop, it is difficult to do it, but we can do it. First, we need to have here some counter. Yes, we know that for loop has the counter, and we have to start from some number, but we can't use this number as initial value. We can't use here 0.1, because the loop, it will be the mistake. And for example, if I want to do it 1 to 1.1, 1.1, I can't do it really. So at first we think that we can do it like this. Yes, because the initial value is 0.1 and we are going to go up to 1.1 and print it out, not x but I here. I have I. And if I run this program, I have this message. This message is an error, and it is the error because I can't use floating point number as the counter of the for loop. So the for loop means that we must have here some integer number, integers here and integer here, not floating point. So I can't do it like this. But I want to do this task using for loop. What I must to do? So we have here arbitrary step in for loop. What can we do in for loop when we use this arbitrary step? So first, for this task, we need to understand how many times I want to repeat my loop. How many times I want to repeat my loop. So here we have the results for 1, 2, 3, 4, 5, 6. 6 times. I want to repeat 6 times. So I need to do this loop started from 0 up to 5. Because I want to start from 0 to 5, it will be 6 times. Yes, from 0 to 5. 0, 1, 2, 3, 4, 5. It will be 6 times. So I want to repeat it. And what I'm going to repeat? Before the loop, I need to assign x to this value again, to initial value. So we have var x. It will be 0.1. And here I'm going to output this x, but I need to do plus I. I is the counter of the loop. It will be plus 0 multiplied by the step. So we have a step 1.1. So if I have this rule, it's like a rule. So first we need to have initial value. Here we have to set from 0 up to how many times. So it will be 5 plus 1 because from 0, 6 times. And here we need to output this x, but plus I multiplied by this step. So look at this first here. So when we have the first repetition of the loop, it will be 0.1 plus 0 multiplied by 1.1. So it will be just 0.1. Yes, 0.1, because multiplied by 0 plus 0 multiplied by something, it will be 0. So we will see this number. The next iteration of the loop, the next repetition of the loop, we will have here 0.1 plus 1 multiplied by 1.1. So let's look at the example. Var, I don't need to have var here. As the result, we have not 1. I'm sorry. We have this step. We have 0.2 step. I just look at another. It's the condition, not step. Here we have the step. So 0.2, of course. And print line. Let's do print line. So we have the same results. Because each iteration, we need to do this. To do this, the second step as I told you, it will be 1 multiplied by 0.1 or 0.2. So it will be 0.1 plus 1.2. 0.2 or 0.2. I'm sorry. Yes? Yes. So it will be the same. Yes. So as a rule, you have to remember that when we have arbitrary step and we use for loop, first we are going to do it's the initial value of x before the loop. Here we have to put how many times we need to repeat, how many numbers of sequence we are going to output. And here we have printed out x plus I multiplied by step. I, it's the counter of our for loop, multiplied by step. So, and one more example, just look at my presentation, one more example. Here we have the sequence from 11 up to 99. And if we use loop, just loop, it's not difficult. So before the loop, we need to put to set x is set to initial value, so 11 must be initial value. Then we have count how many these numbers will be, how many of them. So they are just odd numbers from 11 to 99. There will be 49 of them. So we can count and we can understand it, just odd numbers to 99, and starting from 11, it will be 45 of them. So loop must be repeated 45 times. And here we have to print out x and to increase x by 2. Yes, to increase at x by 2. So 2 is a step of the loop. So it will be increased by 2, again by 2, again by 2, and up to 99. So this task was done using the loop, just loop. And let's look at this one. It's the same results with for loop. So first, we need to put here how many times. If we start from 0, and we must start from 0, we need to put here 244 because 0 included. From 0 to 44, it will be 45 times, repetition of 45 times. Then we are going to print out, here we have the initial value of the x, initial value of what we are going to see. So here we don't need even x, we don't use this x. So initial value plus I multiplied by step. Step, we have 2 as a step. Yes, and it will be the same results. So we can use this for loop to use arbitrary step in our loop, in our sequence of numbers. Okay, is it clear?
Yes, it is. Actually, it's easy.
Yeah.
Okay, thank you. So do you see that almost each task, when we have some repetitions, it can be done with different kind of loops, yes? With all kind of loops, really, in fact. So if we have some task to have some sequence printed out or to have repeated some kind of code, we can do it with different kind of loops, with all kind of loops. But with some loops, it is just better to do this task. With another loop, it is better to do that task. So each task is preferred to be done with some kind of loop. But if we want, we can do it with all of the loops. Okay, so next we have to do some